Okay, here's part 2 of 7.5 solving equations. I split it in half. All right, so here we go. We're doing the same thing. We're solving equations, so we have to multiply everything through by the LCD to get rid of the denominator. So if you look at this equation in E, you probably notice that this denominator will factor into m minus 2 times m plus 2. So now it's pretty obvious, hopefully, to you that the lowest common denominator is m plus 2 times m minus 2. And remember, what do we do with that common denominator? Well, we take every term and we're going to multiply that term by that LCD over 1, and that will help us eliminate the fraction. So here we go. So we're going to have 2m over m minus 2 times m plus 2, and we're going to multiply that by m plus 2 times m minus 2 over 1, plus second one, we have 1 over m minus 2, and we're going to again multiply that by m plus 2 times m minus 2 all over 1. I can see I'm going into the next problem, but that's okay, is equal to 2 over m plus 2, and we're going to multiply that by m plus 2 times m minus 2 over 1. Wow, that took the whole page. All right, so let's see what happens now. So here in the first fraction, the m minus 2 and the m plus 2 cancel out, and we're left with simply 2m plus, when I look at the second fraction, the m minus 2's cancel out, and I'm simply left with m plus 2 times 1, which is simply m plus 2, is equal to, when I go to the right-hand side of my equal sign here, the m plus 2's cancel, and I'm left with 2 times m minus 2. So all of that mess goes down into here. So let's combine like terms and distribute. So I'm going to have 3m plus 2 equals 2m minus 4. This isn't quadratic, so I'm simply going to bring everything with an m to one side. I'm going to subtract 2m from both sides, giving me m plus 2 equals negative 4. And if I subtract 2 from both sides, I'm going to get m equals negative 6. Now let's do a quick check. Well, negative 6, if I plug that into any one of these denominators, will it make that denominator equal to 0? No, it will not. So m equals negative 6 is a perfectly good answer. All right, we're going to skip F. It's very similar to E, but since we've kind of sullied the space we have there, we're just going to go ahead and we're going to skip that one, and we're going to go on to G. Does everybody see that the lowest common denominator is x minus 1? So let's go ahead and let's take each term and let's multiply it by x minus 1 over 1. Okay, when you write it out, does it look something like that? Hopefully. So if we look at this first term, we can see that the x minus 1's cancel, and we're left with 5x is equal to, go to the second term, or the first one on the right-hand side of the equal sign, the x minus 1's cancel again, and we're left with 5, plus, now when I go to this last term, nothing cancels, so I'm left with 3 times x minus 1. So let's go ahead now that we've eliminated the fractions. We can go ahead and distribute 3x minus 3. Let's go ahead and combine like terms on the right-hand side. So that's going to give me 3x plus 2. And go ahead and finish solving. Go ahead, and I will as well. When you're done, compare, see if we have the same answer. And now for the question of the day, does that answer check? If I were to take 1 and plug it into this denominator, what would that give me in the denominator as a value? It would give me a 0. So that solution, by the way, the one and only solution we got, only solution that we got does not check, which means the answer is that there is no solution to this equation. All right, you're going to do H kind of on your own, but I'm going to have you do it in stages. So the first thing that I would like you to do is I'd like to pause the video and I would like you to do this. I would like you to factor all of the denominators and then find your lowest common denominator and then come back. All right, so if we go ahead and factor the denominators, the first denominator factors into x plus 3 times x plus 1. To factor the second denominator, I can take out a 2, which gives me 2 times x plus 1. And to factor the last denominator, I can take out a 4, which leaves me with x plus 3. So my lowest common denominator, I'm going to write it right up here, is, now I have to look at the 2 and the 4 separately. So what's the lowest common denominator between 2 and 4? That's going to be 4. And then I also need an x plus 3, and I also need an x plus 1. There it is. Is that what you had as your lowest common denominator? If not, figure out where that went wrong. Okay, so now I want you to go ahead, pause the video, and do the step where you multiply each one of the fractions in the equation by that lowest common denominator over 1 to eliminate the fractions. And then go ahead and come back and make sure that you've done that correctly before you go on. All right, so I'm going to go ahead and I'm going to multiply every term. I'm going to write it kind of small here so I can fit it by the common denominator over 1. Remember, you're multiplying it by the whole common denominator over 1. Ugh. Still not going to have enough room. So I'm going to really squeeze it in here. So I need the 4 and x plus 1 times x plus 3. All right, so let's see what happens here. In this first fraction, both of the binomials cancel, and I'm simply left with a 4 plus. In the second fraction, the x plus 1s cancel. The 2 cancels into the 4, leaving me with a 2. So when all is canceled there, I'm left with 2 times x plus 3 is equal to, when I go to the other side of the equal sign, the 4's cancel. The x plus 3's cancel, and I'm still left with this 3 times x plus 1. All right, is that what you ended up with when you got rid of those fractions, hopefully? Okay, so once you get to this point, why don't you pause again and go ahead and solve, get your answer, and then come back and check your answer. All right, so I'm going to go ahead and I'm going to distribute the 2. So 2x plus 6, and then distribute the 3 on the other side of the equal sign. I'm going to combine like terms to get 10 plus 2x equals 3x plus 3. I'm going to subtract 2x from both sides. So that's going to give me 10 is equal to x plus 3. And then if I subtract 3 from both sides, you should be getting an answer of x is equal to 7. And that is a very valid answer because there's no way that I could plug in 0 or 7 to any of these denominators and get a 0. So x equals 7 is your answer. All right, so the second part of this, these notes are you're given some kind of equation. Sometimes it's a formula, sometimes it's just an equation. and they're going to ask you to solve for a specific variable. And in this case, they're asking you to solve this equation for capital R. So in other words, you want to get R alone on one, capital R alone on one side of the equal sign. Okay, so I'm just going to take a second and rewrite this equation so I can have a little bit more room. So the first thing I happen to notice with this equation is that it's a rational equation. It has fractions. So I'm going to take and I'm going to multiply both sides of my equation through by my lowest common denominator, which is capital R plus lowercase r. So I'm going to take the first fraction and multiply it by capital R over capital R plus lowercase r over 1. And then I'm going to take the right-hand side, or the second fraction, I'm multiplying it by capital R plus lowercase r over 1. So just the same thing we were doing before. So on the left-hand side, nothing cancels. So I'm left with I times r plus r is equal to. On the right-hand side, the r plus r's cancel, and I'm left with simply an e. So now again, I'm trying to get this r alone on one side. Well, I'm going to go ahead and I'm going to distribute. So I r plus I little r is equal to e. So now again, I want to get this capital R alone on one side, which means I want to get rid of this guy. So I'm going to subtract I little r from both sides of my equal sign. So I'm going to have I big R is equal to E minus I little r. So I'm going through all my steps for solving equations. So now I want to get the big R alone. So how would I get rid of this I? Well, since it's being multiplied, I'm going to take and I'm going to divide both sides of my equal sign by I. So these i's will cancel. Look what's left, just the big R, and that's going to be equal to E minus I little r over I. So your answers are going to be crazy looking rational expressions looking like that. But we've just gone through our steps that we normally would have gone through as if they were numbers, and we've just carried along the variables. Now, I happen to notice a typo. Do you notice a typo in B? It says take that equation and solve it for R. Well, the problem is there is no R, which is kind of interesting. So let's take and let's change the X to an R. So I'm going to have 1 over A plus 1 over B equals 1 over R. All right, so if I look at all the denominators, what's my lowest common denominator? Because I'm going to get rid of the fractions. Well, it looks like simply ABR. So I'm going to take every fraction and multiply it by the LCD over 1. So same steps that I've been doing all along. And this should eliminate the fractions. So I go ahead and the A's cancel, and you can see that I'm left with BR plus, here the B's cancel, and I'm left with AR is equal to, on the right-hand side, the R's cancel, and I'm left with AB. Now, this one is a little bit different. Notice how, and I'm going to show you a trick that you've got to know. Notice how we want to get the little r alone, but there are 2 of them here. So the question is, what algebraic manipulation can I do that would turn these 2 r's into just a single one? And the answer to that question is I can take and I can factor that little r out of this expression. It's a GCF. So if I take an r out, I'm going to be left with b plus a. So notice how the two r's became 1 is equal to ab. So there's the trick right there. Star that, whatever you need to do, factor out. So if the two terms here have that common factor, factor it out. And now, how do I get this little r alone? Well, the little r is being multiplied by that set of parentheses. So how do I undo multiplication? Think back to basics. I'm going to divide both sides of my equal sign by b plus a. These will cancel, leaving me with just what I wanted. R is equal to ab over b plus a, and that does not reduce at all. You can't cancel, for example, this b with this b because this b is part of this whole factor, and you can't cancel part of a factor. So there's the end of 7.5.